Hello, Algebros. We're going to continue with section 8.5 today, and we get to finish 8.5. This is our final section. So after this, you guys will get to move on to the review and then chapter 8 test. Congratulations. Okay. All right, first, a couple of things to review, okay? When we have a word problem that talks about finding consecutive integers, remember, what does consecutive mean? Consecutive means numbers that come in a row, one right after the other. So that would be like 4, 5, and 6. 30, 31, 32. Those are examples of consecutive integers. So in order to find the consecutive integers, they would be, if you say let n be the first integer, then n plus 1 would be the next one, n plus 2 would be the third one, n plus 3 would be the next one, etc. Now, let's say you want to find consecutive even integers. Okay, so we would define our integers as n plus 2, and then n plus 4, n plus 6, okay, because even integers and odd integers also are 2 away from each other, right? Like 2, 4, 6, 8, 10, 12, or 1, 3, 5, 7, 9, 11. From one even integer to the next even integer, you have to add 2, right? Or from one odd integer to the next odd integer, we need to add 2. So 3 to 5 to 7. All right, so we'll see those that utilized in the examples to come here. All right, let's take a look at this here first. Okay, example, 4 times the smaller of 2 consecutive odd integers is less than 3 times the larger. What are the largest possible values for the integers? So first we need to define our variables. We're asked to find the largest possible values for the integers. Okay, so first we have to let n equal the first odd integer. The second odd integer will be n plus 2. Now, it says 4 times the smaller. Okay, so if we take a look at this again, n is the first odd integer. That's the smaller integer. N plus 2 is the second odd integer. That's going to be the larger integer. So 4 times the smaller is going to be 4n of 2 consecutive odd integers is less than, so we're going to use the less than sign, 3 times the larger. Okay, so the 3 times the larger, n plus 2 is the larger integer, right? Now, what are the largest possible values for these integers? So now we have 4n is less than your quantity 3 times n plus 2. So we simplify this, okay? And then we solve it as if this were the equal sign. Okay, so we solve it the same way as we've been doing with our other equations. And then you're going to bring your variables to one side of the equation and leave your numbers on the other side. So we have to subtract 3n to bring it over to this side. 4n minus 3n gives us n is less than 6. Okay, so n, remember, that's our first integer, right? The largest odd integer for n is 5, okay, because to go back here, it's asking for 2 consecutive odd integers. What's the odd integer that is closest to 6, that's less than 6? that would be 5, okay? N is 5. That's the largest odd integer. The second integer would be 5 plus 2, okay, n plus 2, and then that's going to equal to 7. So my two consecutive odd integers are 5 and 7. Now, let's check, okay? If you go back to your original equation, you're going to plug in the smaller integer, 5, on the lesser side, okay? Because this is less than. And then the larger integer, 7, on the greater side. Okay, so does 4 times 5, is it really less than 3 times 7? 20 is less than 21? Then yes, that checks. And your two integers are 5 and 7. Now, this is our trichotomy axiom for all real numbers, a and b. A is greater than b, b is less than b, or a is less than b, or a equals b. So basically it's just saying that we can have two real numbers, a and b. Those, or a and b can represent any real numbers. Okay, so for all of our real numbers, we can have a can be greater than b, a can be less than b, or a can be equal to b. All right, now let's take a look at this next example here. I've got negative 5x plus 7 is not less than or equal to 22. Okay, now I'm going to solve for x. And before we do that though, okay, if this sign right here says it's not less than or equal to, that means that this is greater than, okay? We just take this inequality and you just flip it upside or flip it backwards. In other words, this is telling me that it's greater than. We just took this and flipped it backwards, okay? So now we can take our equation and solve for x. So again, I'm going to bring my numbers all the way over to one side and leave my variable on the other side. So I'm going to subtract by 7 so that this cancels out, becomes 0, and I have negative 5x is greater than 22 minus 7 is 15. Then I'm going to divide by 5 now, negative 5. And remember, when we divide by a negative number, our sign flips over again, okay? So now x is less than 15 divided by negative 5 is negative 3. Okay, now here, take a look at this. It says at most means less than or equal to. At least means greater than or equal to. So those are your key words, okay? In the word problems, when you see at most means less than or equal to. At least means greater than or equal to. Okay, for this next example, it says write the corresponding inequality for the following statements. So you're just going to write this statement into an equation, okay? They're not asking us to solve it. We're just practicing writing this into an equation. 4 more than a number is at most 84. Okay, so at most, which symbol are we going to use? Okay, less than or equal to. Okay, 4 more than a number. So n is our number plus 4 is at most. That means less than or equal to 84. No more than 84. Okay. All right, now let's take a look at this. It says twice a number decreased by 7 is at least 90. So twice a number, okay, 2n decreased by 7 minus 7 is at least, okay? So that's going to be this one backwards. greater than or equal to 90. 40 less than a number is not less than 95. So not less, okay? 40 less than a number. Okay, so a number, any number, y or x or n, less than, okay, 40 less than that would be minus 40. Okay, not less is greater than or equal to. It means it's no smaller than 95. And there's our equation. Okay, now this says 6 more than a number is not equal to 63. Okay, so x, our number, plus 6, okay, is not equal to, just simply not equal right there, 63, okay?